Hello, good afternoon. Hello. Good evening. Am I audible?
Yes, sir, you are audible.
Yes, sir.
And what about my
Yes, sir.
screen?
Yes, sir, audible. Yes, sir.
So shall we start or still waiting for some more?
Sir, you can start.
Okay, thank you. So my name is Sri Kumar G. I'm one of the senior EV trainer in ISIEINDIA India Private Limited. Right now I'm working in Kerala as a. So today's subject is EV-Powertrain. In this, we will discuss about EV inverter or electric vehicle inverter, and also EV motor, motor reduction gear, and finally about the EV powertrain architecture. So what are the various type of powertrains and how we can classify the electric vehicles according to the powertrain architecture? So that will be our core subject. So before proceeding to the EV powertrain architecture, let me show you the EV inverter and then EV motor and also the reduction gear. Here I am showing an entire EV block diagram, or I can show one complete EV propulsion system. So in this, around 13 items are listed. I will show you one by one where exactly all these components are connected. So let us start with the electric motor. In electric vehicle, we are not saying simply motor. It will be motor or generator, because this type of motors can work in both conditions. It can, for moving the vehicle forward and reverse, it will be motor. And while you are applying brake, it can convert into generator mode. So that's why we are not calling simply motor, or it will be motor generator is the best term for this type of machine. The second one is transmission with the differential. So some of the EVs are not using this transmission or differential. There may be only a reduction gear, single reduction gear mechanism, but some EVs are using still transmission and differential. So differential is common if we have, because this depends upon the EV architecture that we will see later. So the second one is transmission with a differential assembly. Third one, power electronics. So you can see the cables connected. Two cables are coming to that particular box, the third one, and then it is supplying power to the motor assembly. So when it is going to the motor, it will be a three-phase connection. Yeah? So that is the power electronics. Fourth one is high voltage lines or cables. So high voltage cables, which is connecting the battery pack to the power electronics. So whenever you need a power from the battery, these cables are supplying high voltage from the battery to the power electronics. Fifth one is high voltage battery. So you can see the battery always located on the chassis side or at the rear side of the vehicle. Depends upon the vehicle type and range, or manufacturer wise, this location and the size of the battery may change. Sixth one, the electronic box with a control unit for battery. Because battery also need a continuous monitoring, and also battery power, how to connect the battery power with the electronic control unit. or our power electronic box. So, and also the battery need to charge. So for that, we have a electronic box with control unit, and that is mainly the major components inside this electronic box is BMS, battery management system computer, and also the junction blocks with the contactor, and finally the contactor relays for the charger also. Seventh one is our cooling system. So you can see the cooling system same like our conventional gasoline or fossil fuel type IC engine type vehicle also have cooling system, because we are using heat power. So this heat engine continuously developing power with the heat that we have to cool down. So in that case, we need a radiator and cooling system in the IC engine type of vehicle. But here also we have because we need to cool down the gearbox. It will generate heat while moving forward and reverse. And also our power electronics box need to cool down. In some models, battery also need a cooling system. Most of the battery need cooling system because we are nowadays using lithium ion as a battery pack. So in that case, battery also need a cooling system. So there is a separate cooling system available. So the system, the design and the components, which depends upon the manufacturer. The Tesla level vehicles using very complicated cooling system. The thermal management in Tesla is very effective. Even from the passenger body temperature also, they can collect the temperature and send it to the battery. Like that system they are using. So eighth one is brake system. Brake system, normally every vehicle have no brake system, but in this case we have one more brake system, that is regenerative brake system. So our conventional brake system will be there. Here in the picture I'm showing the conventional brake system, but it is integrated with the regenerative braking also, that we will discuss later. So we have a brake system because that is directly interacting with the motor and the power control unit. That's why we mentioned in this illustration, it is part of our powertrain system. So high voltage air conditioner compressor. Why we mention this? Because this is electric vehicle or hybrid vehicle cannot use our conventional AC compressor. They are, because if there is an engine, we can connect the compressor because it is a mechanical device. We can connect with the engine through a belt. But in case of electric or hybrid vehicle, there is no continuous engine operation in hybrid, and also in electric, we don't have an engine. So we need a compressor with a built-in motor. So that motor is working with high voltage. That is also part of our high voltage and electric vehicle propulsion system. 10th one is high voltage heating. So in normal, our IC engine type vehicle also using heater system for passenger heating purpose. Sometimes even engine need preheating, and battery pack need heating. When the temperature is below some temperature, below 10 degree, then we need to use heater or heating system to heat the battery and also the passenger cabin, including the power electronics side. Okay, so that's why we need a heater, high voltage heating system. 11th one is battery charger. So every EV having an onboard vehicle charging system or onboard charger, because whenever you connect level 1 or level 2 AC charging, we are not using any external device to convert the AC current into DC. We are using the onboard charging system. So there is a built-in battery charger available in most of the EV. 12th one is charge charging contact for external charging. So there will be a charging port for every vehicle. It is available in if it is EV with the external charging facility. Some electric vehicle like fuel cell or hybrid, full hybrid, maybe not required this, but almost all wherever we need a plugging, we need this facility, charging contact for external charging. And finally, the 13th one is the external charging source. So these are the major components in the electric propulsion system. Now, let us see this major components once more. I will show you in block diagram. So you can see here how they are related. External power source means that is the power supply from our grid or even solar power or wind power. Any power we can connect with our vehicle through onboard battery charger. So that will charge the traction battery. The green one is the traction battery. You can see the green one is traction. So first, external power source, that can be our grid power supply. And the second, the blue, dark blue is onboard battery charger, which is available inside the vehicle. Then that will charge our high voltage battery. So this high voltage battery again connected with the DC-DC converter and auxiliary battery. So we have a high voltage battery and auxiliary battery. Yes. Hello. Yeah, tell me anything in between you want to discuss. Shall I continue? Hello. Am I audible?
Yes, sir. You can continue.
Yeah, okay, thank you. So we have a DC-DC converter, which is converting this high voltage into 12 volt so that we can charge our auxiliary battery. And everybody know this auxiliary battery is the main battery which is controlling the entire vehicle electronics. So the high voltage battery, it is directly connected to the power electronics, and then it is to the traction motor, and then the traction motor will drive the drive wheel through reduction mechanism. So in the controller side, because we are sending the DC voltage to the controller, there we have inverter. So that the controller is controlled by three major components, which is our accelerator pedal, because when you press the accelerator, the vehicle speed may increase or decrease. And brake depends upon the brake pedal application. The controller will reduce or turn off the motor power and convert that motor into generator, and we can get some regenerative power back to the battery. And also the hydraulic brake system. So there is a collaborative operation between the regenerative braking and the hydraulic braking. So that's why the hydraulic brake system and brake pedal both are connected to the controller. So they will decide what should be the top priority when you press a brake pedal in a slow, in a moderate mode. I mean, we are not in the emergency situation, just partially applying the brake pedal. That time we can apply maximum regenerative brake. And when you are in emergency situation, the hydraulic brake will play a major role. Okay? That will apply in the maximum. Now, the traction motor, again, one more component is there in between the drive wheel. There is a reduction mechanism, because traction motor can go up to 14,000 RPM, not same like our engine. Engine can rotate up to maximum 6,000 to 7,000 RPM, but here it may go up to 14,000 RPM. Some model it is more than that. So we can use a reduction mechanism to multiply a permanent reduction mechanism, because we are not changing the gear ratio in the electric vehicle like our conventional vehicle, first gear, second gear, third gear. So we are using a single speed reduction gear. Then it is directly connected to the drive wheel through differential. So that is the entire or we can see the entire electric vehicle drivetrain system, or we can say these are the major components and how they are integrated together. If you want to see the this is just like a block diagram. I'll show you in the vehicle how it is integrated. So here I have a sample illustration. Actually, this is from one of the major manufacturers' EV system. So here you can see the electric vehicle transaxle, the dotted line showing the entire transaxle. Inside we have motor and reduction mechanism with the differential. Differential is nothing just for differentiating the front wheel left and right speed variation for that purpose. While you are making a cornering or in a off-road purpose or even in an irregular surface, we need to differentiate the speed from left side, maybe different speed, right side, maybe different side, depends upon the road condition. So normally this is the differential purpose is to make the difference during cornering. But if your vehicle, any tire going abnormally or more than the speed of the left side or right side, that time that differential will differentiate that speed variation. And we have an inverter with the converter assembly. So this yellow color showing that is AC power supply, and the green color wires are showing the DC power supply. So the bigger, you can see a big box, green color, that is the DC high voltage battery. And we have onboard charger and the charger connection. In some model, both will be in one side, like a combo connector. Both the DC and AC charging can do in one port. And we have the cable which is connecting for charging. Okay. That's all for the component. Now let us see the inverter converter. An actual inverter converter looks like this. Here you can see the DC cable which is coming from the battery directly connecting to this inverter converter unit. And we have a 12-volt connection which is connecting to the VCU, vehicle control unit, or the main computer for EV or hybrid. We have a major computer. So that computer controlling the internal electronics. So inside what we have power electronics. I'll show the internal components. Looks like this. When we open the inverter converter assembly, there we have power electronics like IGBTs or silicon carbide MOSFETs. That is the latest one. So most of the vehicle nowadays using IGBTs, and also cooling system, capacitor, inductor for boosting. To convert the DC into AC, we have a inverter. To convert the AC into DC, we have a rectifier. Both diodes also available, power diodes also available internally. So those components are the major components of this inverter converter assembly. I can show you a sample diagram. Normally, this kind of circuit is used inside the inverter converter assembly to convert the DC into AC. Same time, there is diode available. You can see parallelly IGBTs are there and parallelly diode also provided. So this diode, when we send the power from our generator to the battery, we need a diodes. When we are sending the DC in the form of AC, we need IGBTs. So both function can take place in this area. Okay. And these devices continuously generating heat also, so we need cooling system. And this components, all this circuit in the form of power electronics components accommodated inside this box, that is inverter converter assembly. So when we go to the other type of manufacturers, they are, I have one more type of inverter converter assembly, like Toyota, Lexus. They are using similar type of inverter converter. Previous one from European version vehicle like BMW, Volkswagen. So the entire inverter converter and also the DC-DC converter with battery pack, I can show you the entire vehicle control system diagram. Looks like this. Here you can see the high voltage battery and also the vehicle or VCU or electric vehicle control computer, and which is connected with another two computers are there. MG ECU mean motor generator computer and DC-DC converter, and also the compressor. So these are the major components already we have seen. This part is our inverter part. And you can see a three-phase connection connected. That's why UVW. So this three-phase connection connected to the motor generator. And the DC power source coming from high voltage battery, positive and negative, supplying to the inverter converter. And from the same positive negative, we are connecting to the DC-DC, we are connecting to the compressor. And then low voltage control signals are sending from computer to computer and also to the inverter side, so that we can increase or decrease the power of the motor, or we can convert the motor into generator. That's all about the inverter part in the EV powertrain. Next one is the motor. So motor is the one generating torque or power to move the vehicle. So here I'm showing a sample motor, three-phase motor. You can see that the three lines, here also three lines are coming. The part into construction components, you can see here, electric motor generator. This is the electric motor generator. This entire unit is electric motor or generator. The middle part is rotor. You can see this is the rotor. And stator, the external one. So this is the stator, the external one. That is stator. And the power electronics, we have a power electronics here, the fourth one, that power. Normally, these wires are connected to the power electronics. So this is the actual motor. And here, this is the diagram. And inside the power electronics, normally we are using diode and IGBTs. Then high voltage battery. Sometimes the battery voltage is starting from 170.16 volt, or sometimes 201 volt, 330 volt, 300 volt, depends upon the range of the vehicle. The power voltage may reach up to 800 in the future, and because manufacturers are thinking about how to reduce the weight of the power electronics and motors, and we can improve the performance by increasing the voltage. That's why voltage may go further high. So this is the motor. When you combine the motor with the other mechanism, like cooling system is there, lubrication system is there, and also the reduction gear. So when we combine all this together, we call transaxle. So you can see here, the motor is not directly connecting to the wheel. We are connecting the motor with the help of a reduction mechanism. Normally, two types of reduction mechanisms are there. I'll show you here two types of reduction. One is the planetary gear type of reduction mechanism, and the normal gear-to-gear reduction mechanism is there. So when the motor will drive a small gear, and then it is going to a bigger gear. So when the motor rotates 10 times, the output will rotate 1 time. Like that, 1:10 reduction will be there. So I can show you one assembly here. Entire motor with the reduction and differential attached in the driving side. So here you can see the motor and the reduction mechanism casing with the differential. And these two axes are going to the left side and right side wheel. So there is motor, reduction gear, and differential. Okay. Normally, the transaxle and the inverter converter assembly will come as a unit. You can see here that the blinking one, the blue one, that is the inverter converter assembly. So when you open the engine hood of any electric vehicle or hybrid vehicle or fuel cell vehicle, when we open, not Ola and either, the other Ampere, Hero Electric, they are using hub motors. So there is no reduction mechanism, no any fixed gear available. So mechanical gear system is totally removed in this case. And controlling the motor speed is controlling directly with the motor is directly connected to the wheel. So the motor speed and wheel speed will be same. Okay. And there's another arrangement like a high-end model like Tesla, BMW. They have two motors in the rear side, rear wheel drive configuration. Examples. Okay. like a all-wheel drive, two separate individual motors in the front side and rear side. These are the models available. Now we have other type of electric powertrain available. Electric vehicle mean electric vehicles are classified into hybrid, plug-in hybrid, fuel cell vehicle, battery electric vehicle, a range extended type electric vehicle. So let us see one by one what are the other type of powertrains in EV sector. So here I am showing full hybrid, plug-in hybrid, electric vehicle, that means BEV, battery electric vehicle, range extended type of battery electric vehicle, and finally fuel cell electric vehicle. So we are just comparing what are the components attached in all this, and also what will be the benefit, I mean the potential CO2 reduction in each model, what will be there. Okay, so let us see one by one. First, the full hybrid. Now Suzuki already introduced a full hybrid. There we have a engine, motor with a reduction, power electronics, and also high voltage battery. So these are the major components in the powertrain side. There is no charger required, external charger, or no any externally charging mechanism available. No onboard charger in this vehicle. So just petrol enough. So there is no petrol, this type of vehicle will not move. The next one is plug-in hybrid. So plug-in hybrid, additionally what we have, there is charger, external charger we can use. In case of full hybrid, we are saving only 25% reduction in, when you are using, compare with the other conventional vehicle, we can save 25% CO2 reduction. But in this case, 50% we are saving the CO2 emission. So that's the importance of plug-in hybrid. And plug-in hybrid vehicle is almost similar to electric vehicle. And advantage is wherever you go, you don't have any charging facility, you can just fill fuel and go. If there is charger available, you can charge your battery and you can go use your vehicle like an electric vehicle. That is the advantage of plug-in hybrid. So these are the components in the plug-in hybrid. Engine will be there, motor with a reduction, and power electronics, then battery, and we have a charger, external charger. In case of BEV, there is no engine available. Okay, so the difference between all this, there is no engine. 100% CO2 reduction, 100%. And we have only motor with the reduction, power electronics, battery, and charger. Next one is a range extender. Maybe many people are not familiar with this. This range extender means it is almost the same like a plug-in hybrid, but the function is not same like hybrid vehicle. It will be 100% electric vehicle. But if your battery is not charged, or if there is a charging issue, no charge facility available outside, then we can use the built-in engine to extend the battery capacity. For example, your battery is giving only 300 kilometers, but with the fuel available in the tank, we can extend the range to 500 kilometers, depends upon the tank capacity. So there is an engine available to charge the internal battery. That is the speciality of a range extender type of battery electric vehicle. So additionally, what we have, it is same like plug-in hybrid. So the function is totally different in this case. And finally, we have fuel cell. So fuel cell means there is no engine. Instead of engine, what we are using a fuel cell stack. So fuel cell stack directly converting the hydrogen and oxygen supply into electricity and producing electricity and water. So the water will be the waste like exhaust, and the electricity we can directly store and use to drive the motor. So it is 100% electric and 100% CO2 emission free. There is no charging facility. That is why charger is not showing in this. So no charge facility required. No onboard charger also available in the fuel cell vehicle. Okay. So with that, we are coming to the end of our session. So we can discuss about the subject today is powertrain. How it was? Any question? Hello.
Hello, Dhanesh.
Hello. Yeah, tell me. Am I audible?
If you have any questions, please ask from the sir. Any doubt, you can ask. Sir, please check the chat box.
Yeah, in the chat box we have Ajay Kumar. Range extender. Range extender is just it's not same like a plug-in hybrid. The components are similar to plug-in hybrid, but if you have any charge facility available problem, for example, when you are going rural area, these type of vehicles can use an internal engine, built-in engine, to extend the battery capacity by charging internally by the help of an engine. Clear? Another one, Nagendran, relationship between battery torque and battery voltage. See, we need to generate higher torque. So to produce higher torque, either we have to increase the voltage or current. But current, we have limitation, because when you go for higher ampere battery capacity, if you are arranging for higher ampere, then we need the power electronics and also all the contactor, wiring harness, terminals, everything must be higher capacity. So that will increase the entire vehicle weight and the cost of the vehicle. So the best way, we are increasing the voltage. So ultimately, when you multiply the current into voltage, you will get the power will be same. So torque, you can multiply with the voltage applied. Any question? Is it clear? I think it's clear now. Nikhil Prakash, how the charging system works in plug-in hybrid and how it is drive the vehicle fully with electric charge or partially. Okay, plug-in hybrid vehicle using, compare with the full hybrid and plug-in hybrid. Plug-in hybrid battery capacity will be double than the full hybrid, or we can say bigger battery we are using, but it won't be similar to the battery electric vehicle battery size. Comparatively small, but bigger than full hybrid battery. So what is the advantage? The battery can charge more current. So we can charge them externally with the help of an onboard charger. So with the help of DC charger also, we can charge our plug-in hybrid if you need fast charging. But otherwise, normal charging like our BEV. The battery which is available in the plug-in hybrid is comparatively bigger. So the EV mode operation will be larger than the conventional full hybrid vehicle. We have two model. One we can compare like this. There is Prius, Toyota Prius plug-in hybrid, and we have Suzuki Vitara full hybrid. So Suzuki Vitara full hybrid using a small battery at the backside and Prius using a bigger battery in the backside of the vehicle. So when you charge externally plug-in hybrid, the range available in the EV mode is comparatively high in our plug-in hybrid vehicle. So you can have more EV mode compared with the conventional full hybrid. That's why we have a advantage in the plug-in hybrid. In US market, majority opting nowadays plug-in type hybrid vehicle because you can, if there is charging available, you can directly charge the vehicle and use like a electric vehicle. Separate button provided to switch from hybrid mode to EV mode. So if you want to use your vehicle like an electric car, simply press the button and you go for. But there is condition in case SOC, state of charge of the battery, is dropping after certain threshold values are there. When it is dropping below that, then automatically it will switch into hybrid mode. I think clear your doubt. Type of motor, because here we are focusing more on, we have any type of motor, BLDC type, PMSM type, then reluctance motors are there. So generally nowadays in the market, we can see more on PMSM type, permanent magnet synchronous motor, and also BLDC in the two-wheeler and three-wheeler sector. So these are the major, largely available types, but reluctance motors also available. But in today's subject, we focus more on powertrain arrangement. In next section, when we discuss, especially for the motor side, we will show you the different type of motors available in the EV sector. Engine torque, relationship between engine torque and battery voltage. Engine torque and battery voltage in which vehicle? Can you explain it? Who was that? Nagendran. Kindly explain the relationship between engine torque and battery voltage. There is no direct relation between engine and battery voltage. In case of hybrid vehicle, engine we are using to generate electricity same time. It depends again with the type of hybrid. We have series parallel combination, complex type. So when we are using a series parallel combination, the voltage is applied only onto the motor side. Engine is driven with the power of engine rotating with the power of fuel. So that generated mechanical energy converted into two separate areas. Again, that is distributing to wheel 30%, 70% going to the generator side, and generated electricity we will decide. There is a checkpoint. So whether we need to use the fully generated voltage go back to motor, or you can save some amount of electricity to the battery and some amount sending to the motor. So that is the logics available in our hybrid vehicle controller. There is no relation with the engine and voltage. Engine is totally independent. That will work with the help of engine ECU, but the generated power requirement based on the engine RPM. So, and that is depends upon the accelerator pedal condition and the vehicle SOC, battery SOC. Based on that, the engine rotation may go higher RPM or lower RPM, or different the power output can achieved with the calculation based on the torque. What is the target torque and what is the current battery SOC? So we will consider both, and then only engine RPM will vary. So there is no direct relation between voltage and engine. Any other question? Yes, any direct question? I think in the chat box, most of the battery management system algorithm. Again, Nagendran, battery management system algorithm. Battery management we are using, see, battery management is directly connected to the battery power supply. I mean, how you are sending the battery power to the engine, I mean, the motor side. Same time, we have many other control logics like battery, high voltage, low voltage, individual cell, high voltage cutoff, low voltage cutoff, temperature management. Then we have to operate the cooling system. That is also part of job of the BMS. Then current, how much current is drawing and how far you are, how long you are drawing that amount. When you are charging, what will be the rate of current to each individual cell? Cell balancing is there. So many actions are happening inside the BMS. So BMS is it alone a very big subject. So these are the main functions in the BMS. One is cell management, the cell voltage, cutoff voltage, low and high. Then because it won't allow the battery cell voltage to drop, depends upon the chemistry, there is some cutoff voltage. It won't allow the battery voltage to drop below that. Hello? And same time, it won't allow the higher voltage limit also. So when the voltage level in each cell reach to certain higher voltage limit, automatically BMS will shut down the charging process. So that is one of the function. And we have a cooling function controller, thermal management. That also BMS will take care. Will turn on the cooling system and control the temperature. If you overcool, also problem. So we need to reduce or stop the cooling function when the temperature reaches to certain limit. So that also with the help of BMS only. Then the current, how fast you are taking the current from the battery, how fast you are charging the battery. Both drawing and discharging and charging, both function will manage or monitor by BMS. And the contact breaker, contactors. So when you turn on the ignition, BMS will check the voltage in the contactor on or turn on procedure is there, because normally we are using 3 contactor for operating 2 wires. There will be a pre-charge operation. So for that, we need 3 contactors. So contactor, when you are connecting the power with the power control unit, and the same time when you are charging the vehicle with the external power source, another set of contactor. All this contactor operation with the help of BMS only we are doing. And same time, vehicle safety systems like airbag. When there is a collision, immediately the BMS will shut off the power supply with the help of contactor. Another thing, in case of any high voltage leak to the automotive body, when the high voltage is leaking to the body, immediately the battery power will shut down and it will prevent the high voltage leak towards the body. So when we go to vehicles, depends upon the type of functions available in that vehicle, we may have more functions in the BMS side. Any other question? Hello, what happened? Very silent. Yes. You're welcome. Open. Yeah, you can. Either send your question through chat box or you can ask directly, no issues. Hello?
No, sir. No, sir. No.
I think almost all questions in the chat box is answered. Is there anything pending? Because when I go through the chat box, I have seen only a few questions. Some of the questions are similar. Hello? Yeah.
Yes, sir, I'm audible to you.
Yes, yes. Tell me.
Yes, sir, I have two, three questions. So the first question is regarding the life that all the vehicles that you talk about regarding the battery electric vehicle, heavy electric vehicle, and the fuel cells. So I want to compare when I compare the life of that particular vehicle. So can we have that comparison on that particular end of life or a vehicle life?
Vehicle lifespan for EV, battery electric vehicle, fuel cell vehicle, depends upon the components what we are using. Correct? Hello? Am I audible?
Yes, sir.
Yeah, so we have a hybrid vehicle. So the hybrid vehicle, there is engine available. If you are not doing proper maintenance to the engine, then the vehicle life may be affected. If you are not properly managing the battery charging is automatically happening. That's why hybrid vehicle, you can get a maximum battery life because the lifelong, the battery charging procedure is done by an electronic circuit only, not by human. BEV, we are the one charging and discharging the battery. Whenever our vehicle battery become low, we will go and charge again. So in case of a hybrid vehicle, the battery life, maximum battery life we can have because the charging and discharging managed by BMS. Okay, and there is no need to charge that battery externally. But in case of plug-in hybrid, there may be possibilities are there, but still the vehicle lower limit cutoff voltage will manage by the HV control ECU and the BMS. And in case of fuel cell vehicle, the lifespan depends upon the fuel cell stack. There is a fuel cell stack. Stack means the one who is generating electricity from hydrogen and oxygen. So when you are supplying hydrogen, hydrogen is 100%, we can say it is pure. There is no chance of dust to accumulate inside because, you know, the thickness of one fuel cell, which is developing one voltage, is almost 1.1 mm, something like that. So we have around 300 cell serially connected, like that stack we are using. So there may be a chance of dirty air if you are not properly changing the fuel air filter. Air filter, like same our engine. We have air filter and air compressor in the fuel cell vehicle. So that air filter may damage the fuel cell. So maybe we need to remove the fuel cell, dismantle it, clean it, again assemble it. But it won't totally, the life can be rebuilt again with the help of qualified technician. But it won't be like the battery is there. Even in FC, it is a hybrid vehicle only, fuel cell hybrid vehicle. So we have a small battery like hybrid vehicle. So that battery life will be the end of whenever the battery voltage the cycle is over. So we need to replace the battery. Otherwise, these vehicles can give longer life plus less maintenance. That is the advantage of electric vehicle. If you go to the maintenance side, just compare or check with anybody who is using electric vehicle,
They may have some battery issues or charging station availability issues because of their usage or the location and availability of charging facility. They may have concerns, but they are very happy with the maintenance cost. There is no oil, no need to replace the engine oil frequently. There is oil in the drivetrain gearbox assembly, but it is long duration, no need to frequently replace. Longer life oil we are using, and coolant maybe need to replace, but spark plug, gasket, oil filter, oil, canister, fuel filter. So many items are eliminated from the electric vehicle side. So you will save a huge amount in the maintenance side. And life of the vehicle also comparatively high because there is no much heat in the engine cabin. There is no much vibration. So these are all giving longer life. But motors maximum, if you are properly changing the oil, then maximum we can say there is no maintenance at all. If your operation is normal, there may be abnormal operation. Some depends upon the customer, like abusing conditions will be there. In that case, maybe yes, motor short circuit issues are coming. Overheating problems will lead to the short circuit. So many issues are there. But otherwise, all electric vehicle having longer life than the conventional vehicle. Yes, tell me. Any other question? Yes, Darshan. Yes, you can ask. Diroshan. Yeah, I think your mic is muted. No, everybody's mic. You can unmute your mic and ask. Hello? If there is no much questions, so shall we wind up this session?
Hello.
Yeah, tell me.
So one more question regarding the trending technology or the coming technology which are in the pipeline related to the particular components in all the segments regarding suppose battery. So sir, what is the latest technology that we are implementing domestically or internationally, or suppose motor? So what kind of research is going on that area? So sir, can we have that overview, the latest updates, the particular components?
Yes. Each manufacturer, they have their own research and development area for all the components. As I mentioned in our presentation, power electronics side, nowadays, all manufacturers are thinking about high voltage components like silicon carbide MOSFET transistors, power transistors, not IGBT. IGBT have limitation because we need faster switching, and also the voltage handling capacity must be more than 800. So the MOSFET with the silicon carbide can go up to 1200 voltage, so that we can reduce the size of the motor, reduce the control circuit size. So that's the main advantage when we go to higher, and the performance will be high. So that's why power electronics side, many manufacturers now thinking about switching from IGBT to silicon carbide, plus the voltage level they want to increase. Another advantage with the silicon carbide MOSFET, their heat generation comparatively less. So we need only limited cooling facility. So cooling system also creating lows so that we can reduce. Another thing, battery side. Battery also a lot of research all over the world. Many new prototypes and new ideas are there, but Some of them are not applicable in the mass production. We may have spend, mean the cost of the production will be very high. That's why some theories are not applicable to the market. It is only up to the research level. When you want to make mass production, then the cost will be very high. And recently, everybody knows about solid type batteries. Solid type batteries will be the future, and at the same time, fuel cell. Heavy vehicle side, maybe more manufacturers will come with the fuel cell technology. Like Tata already have their prototype, or last maybe next year they are planning to launch. Only the issue is hydrogen filling facility must be everywhere in India. Then only we can introduce this type of vehicle into the market. So first we need a hydrogen filling station. So soon our metro city may available with the hydrogen filling facility, so that trucks in that area, especially the city buses, will switch into hydrogen. Hydrogen combustion engine also available nowadays, but that is again we are going back to the moving components may need maintenance. So instead of using hydrogen engine, maybe hydrogen fuel cell will be easy to convert that hydrogen into electricity, and then directly we can use motor and battery to manage the generated power. That type of innovative ideas from every manufacturer side, the new things are coming. And another advantage, the battery cost is drastically coming down. You can compare the cost of our lithium-ion example, 18650 battery, that cylindrical cell, NMC battery. Now, what is the cost? And before 2 years, what was the cost? You can just compare, then you will understand, or you can take the 2019, what was the cost, 20, 21, 22, 23. So the 5 years battery cell cost, you can just have a study and make a graph. You will see the graph is going down, because gradually the cost of the component will reduce. Now, why electric vehicles are a little bit costlier here? Number one is battery cost. Second, most of the control circuit we are importing from many other places. When we have local production, again, the cost of the vehicle will come down. I feel like next year there will be more electric and hybrid vehicle from Suzuki, from Mahindra, from Toyota, from AMG. Many manufacturers now they are planning hybrid also, because hybrid, at least a plug-in hybrid, can reduce the CO2 emission, as we discussed in our presentation. Another thing, they can meet the Euro 7 or Bharat Stage 7 emission requirement. So before reaching to the 100% e-mobility or electrifying, that target is 2030. But to reach that 2030, immediately we have a lot of hurdles like charging station availability, hydrogen filling station availability. So hybrid will be hybrid can act like a transition technology towards the electrification. So from conventional IC engine, we will move to hybrid. From hybrid, gradually we can go to electrification, 100% e-mobility. So that is the plan of our government. So based on that plan, more hybrid vehicle will be available, and the opportunity of young engineers also gradually improving, increasing everywhere. The requirement is there. So it will be totally a different sector. That's why more academics are coming, more institutions are coming in the training side, in the certification side, because every manufacturers, every service organization, service people, or even in the battery manufacturing side, they need qualified and certified people, at least, because there are a lot of, it is not conventional automobile designing. The conventional designing was not, some part maybe we can say body and rubber, totally different platform. EV is totally a different platform. Everybody knows that you compare the MG and Tata Nexon. Now Tata Nexon reached to their EV platform. Earlier, they were using a conventional gasoline platform for a EV. Now they are also, so everywhere opportunities are there, because totally new vehicles development, testing, sales side, service side, everywhere opportunities are there, but you have to have a certification for that. Thank you very much for, if any question, if anything need to clarify, I'm ready to stay further. Otherwise, shall we wind up? Hello?
Yes, sir, you can.
Yeah, thank you. Thank you. Thank you very much. Yes, sir, you can start our ISI presentation.
Thank you, sir, for this wonderful webinar. Hope everyone like this. And the certificate will be shared by today 9 p.m. on your mail, okay? Thank you all of you for joining. You can leave.
Okay, thank you. Thank you. Thank you very much.
Please fill your feedback on Google review about webinar. The link is shared in chat box. Hope everyone liked this session. Please give your review about the session. Please fill your feedback on